Welcome to this explainer. When you picture Canada, you probably think of snow-capped mountains, maybe some hockey, and endless pine forests. You definitely don't picture violent, swirling vortexes of wind. But today, we're unpacking some source material that literally flips our understanding of the Great White North entirely on its head. We're going to break down the causes, the heavy impacts, and the absolutely crucial preparedness strategies surrounding the Canadian tornado.
Okay, let's just dive right into this with a statistic that honestly blew my mind. Canada actually experiences more tornadoes than any other country in the entire world, except for the United States. That is wild, right? The global #2 spot for these devastating storms belongs to a country famous for ice and snow. We're not talking about some tropical nation near the equator here. Yet, the data strictly shows that Canada is a massive runner-up on the global stage for these violent storms.
So this naturally begs the question, why Canada? Why is a country famous for its freezing winters a global hotspot for late spring and summer tornadoes, especially in provinces like Ontario, Alberta, Saskatchewan, and Manitoba? What exactly is happening in those specific areas during the warmer months that transforms this peaceful landscape into a total breeding ground for extreme weather? Well, to really get it, we have to look up and examine the massive invisible forces at play high above our heads.
Which brings us to part 1, the science of the spin, focusing on atmospheric conditions.
Let's put on our meteorologist hats for a second. It turns out the Canadian atmosphere is basically the perfect mixing bowl for violent storms. It's an invisible atmospheric battleground. Picture this. You've got warm, super moist air traveling thousands of miles up from the Gulf of Mexico, pushing relentlessly north. And at the exact same time, you have freezing, dry, dense air from the Arctic plunging south. When these two wildly different air masses slam into each other right over Canada, the atmosphere destabilizes incredibly fast. It's a high-stakes clash of titans, and the immediate result? The brewing of some intensely severe thunderstorms.
And here's where the geography comes in. The large, flat regions, particularly the Canadian prairies, aren't just great for farming. They actually act as a high-speed collision course for these air masses. Think about it. If you had massive, jagged mountain ranges blocking the middle of the country, those air currents would just break up and fall apart. But that vast, flat, uninterrupted arena, it lets the air move totally freely. It picks up speed, gathers energy, and creates the absolute ideal, unobstructed conditions for a tornado to just spin up.
And when these storms do start to rotate, they form what scientists call supercells. Now, a supercell is not your average everyday summer rainstorm. It's more like a towering, highly organized engine, perfectly designed to just drop tornadoes right out of the sky. The collision of those hot and cold air masses over the flat prairies is exactly what gives birth to these monsters. Understanding this is key because it really shows you just how structured and unbelievably powerful the forces behind a tornado are, way before the funnel ever even touches the ground.
Now let's move into part 2, impacts and destruction, looking at the devastating toll of these events. We really need to ground ourselves here and look seriously at the human and structural toll these atmospheric collisions cause. Because, it's one thing to geek out over the fascinating meteorological science, but the reality on the ground is completely different and far more sobering. A tornado doesn't discriminate. It will completely level agricultural livelihoods, wipe out crops, snap power lines like twigs, and absolutely tear through residential neighborhoods. And beyond all that structural damage, the sudden injuries and tragic loss of human life are the most devastating consequences. This is exactly why understanding this stuff matters so much to every single one of us.
Let's shift gears to part 3, preparedness and prevention, focusing on mitigation measures.
So, the source material is super clear here. We obviously can't stop the atmosphere from doing its thing, but we are absolutely not helpless. On a personal level, surviving a supercell really just comes down to manageable, actionable steps. You've got to be ready before the sirens ever sound. Step 1, the emergency kit. We're talking non-perishable food, bottled water, flashlights, your medications, and a solid first aid kit. The whole shebang. Step 2 is just as crucial. Develop a family emergency plan. You need to know exactly where to go, like a basement or a windowless interior room, the literal second that warning comes through. Preparation is, for sure, your absolute best defense.
But notice how this actually goes way beyond just your house. True safety requires a massive societal effort too. Upgrading our forecasting tech to issue faster, more accurate warnings is a real game changer that saves lives. Running emergency drills in schools means our kids know exactly what to do when the pressure's on. It also means building stronger structures, engineering homes to withstand incredible winds, and actually installing safe rooms. We literally have to build resilience into the very fabric of our communities.
And there is a bigger picture here. The source material explicitly warns that as long-term climate change drives up global temperatures, the atmosphere becomes even more unstable. It's basically adding fuel to the fire for these severe weather events. Remember that epic collision of hot and cold air we just talked about? Well, as the globe warms, we're pumping way more heat and moisture into the system. The data points out that this heightened instability could lead to not just more frequent severe weather, but potentially way more intense tornadoes too. It's a huge wake-up call that our changing climate isn't just about things getting a bit warmer, it's about the increasing dangerous volatility of our skies.
Which brings us to a really critical question. Will our climate action today calm the supercells of tomorrow? Since reducing greenhouse gas emissions and promoting sustainable energy are key to addressing this threat, we have to ask ourselves what role we're willing to play. The source positions this kind of large-scale climate action as a vital prevention measure. It's the ultimate big-picture solution. So, knowing that our collective actions today directly influence the atmospheric instability of tomorrow, what steps will you take to prepare your own home, and what will you do to support broader action to protect our communities? Think about that for a bit. Thanks so much for joining me for this explainer.